Okay, so now that we've seen the hyperbola and how it's constructed, and if you haven't seen that video, you should go back and watch that video first. Let's talk about how to make the equation for the hyperbola. I think that's what this video is going to focus on. Okay, and this probably won't make sense if you haven't watched the initial video that we did, right? Okay, so to do this one, let's assume that we're centered at 0, 0, and that our foci are going to be on the horizontal axis for ourselves, and that one's a little bit further out. Okay, right, and it doesn't matter which one's focus 1 and focus 2. What we need to remember from what we did before is that both of these have a length of c, right? The coordinates of this point being negative c comma 0, and the coordinates of this point being c comma 0. Okay, for ourselves. Okay. So, and then we have a point, and we'll call this random point up here x comma y. Excuse me. For ourselves, and we have to remember that from what we saw before is that this distance minus this distance is going to equal is going to be a common difference for ourselves. Okay, and hopefully it makes sense to you that this is our A, so right, because our A is inside of it. We saw that the vertices, vertex 1 here, vertex 2 there, right, our vertices were inside of it for ourselves. Okay, so now it's important to think about this one on the bottom, because this will actually tell us what that common difference is going to be. Okay, because this distance right here is c minus a for ourselves. So if we're at this point, if we're at vertex 2 right here, okay, this length right here would be c plus a. Right? This whole thing would be c plus a. Okay, and that would be c minus a. Okay, so our difference would be c plus a minus c minus a. Okay, from the longer minus the shorter. Okay, and if we were at this point, we'd have the same thing, right? So, and that would be c plus a, distribute the negative. So we can see that our common difference is always going to be 2a, right, for ourselves. So this right here is our common difference there. So this is the transverse axis, right? So this is the length of the transverse, right? And okay, it's 2a. Okay, so we don't call it a major axis anymore. There's no such thing as a major and minor axis. It's just one axis that's really gonna come to play here. Okay, so that right there is our common difference, right? The 2a. So if we think about this point up here, excuse me, the distance here from this point to this point, well, I can use my distance formula. So that's going to be c minus x squared. Oh, I'm sorry. Let me do x minus c. Just because that's how I have it in my notes. It doesn't really matter. X minus c squared plus y minus 0, and by doing it that way, I can make sure that there's fewer negative signs. Okay. So, and which one's larger doesn't really matter for ourselves. Right, I did this one first, but really, actually, in this case, it should be this is really the case. But it could flip-flop. It doesn't really matter. But if we're doing that point, then this distance is the larger, and this distance is the shorter. Okay, and we saw from what we just talked about up there that common difference is going to be 2a. Okay. So, how am I going to simplify that one? Well, this one we're going to simplify very similar to how we simplified other ones. We're going to move this over. We're going to square both sides then. Why? Because I'm trying to get rid of those square roots. While I'm doing that, I might as well distribute this out. So I have x squared plus 2xc plus c squared plus y squared on the left side, and the other side is going to be 4a squared right? Plus 4a, that quantity. Here's my middle term, and then my last term is just going to be the x squared minus 2xc plus c squared plus y squared. Right? When I distribute this out, and the square root cancels. Okay, this works out pretty nicely because the x squareds cancel, the y squareds cancel. Right from us. Oh, the c squareds canceled as well. Okay, and if I move everything that's not a square root to the left, that would give me 4xc minus 4a squared equals 4a square root of this stuff in the middle. Okay, how about I divide everything by 4 just to make my numbers a little bit smaller. Okay, and then I'll square both sides. Right, now when I square both sides, this is going to be distributing, but I'm distributing, right, just the ones that don't have square roots. Okay, so let me just double check all my distribution, because I don't have you guys in class to fact check me. I'm going to check right here. Okay, right, if I distribute now the, oops, what am I writing there? Okay, I get all of that. Oh, sorry, I was off the bottom there. Okay. Okay, so we have all that step. I'm just double checking I did all my math right. Okay. Right, that term cancels that term. That's convenient. Right, that was nice and helpful there. Right, and let's see. And okay, just see if there's any other terms that cancel. So we have the x squared c squared minus x squared a squared, if I bring that over, okay, minus a squared y squared. So I'm putting basically the x squareds and the y squareds on the left, right, for myself, and I'll move everything to the other side. So a squared c squared minus a to the fourth. Okay. Alright, just double checking all my work here. Okay. At this point, if I factor out x squared from these two, I get this. I factor out a squared here, I get this. Okay. Okay, so I have this piece right here. All right. And so I'm starting to get to a point right now. If you remember before, we had like a b squared involved, and so we're going to try to figure out where we can get that b squared from. So it would be, what we're basically going to do is we're just going to say, okay, instead of writing c squared minus a squared, right, we're just going to make, right, we're going to set b squared to equal c squared minus a squared. So that's going to make things look a lot easier. Right? And you may say, well, that seems kind of random. Well, we are just making this so we don't have to write that, and that's why it's okay. If I divide both sides by a squared b squared, that cancels, so I'm left with, right, and this is the equation for a hyperbola that is centered at 0, 0, and whose transverse axis in the horizontal direction. You can see it looks basically identical to the ellipse, except it has a minus in front of it. Okay, if we had instead had the transverse axis going up and down, then our a would be going up and down. So this is, right, this is a center is at 0, 0, and a horizontal transverse axis. Okay, if we had it centered at 0, 0, but vertical, then basically the y squared and the x squared would flip-flop, right? Because that's all that would change. The a is now going up and down for ourselves, so that's why the y squared would be there and the x squared would be there. If we had a translation, well, translations, we saw they just affect the x and the y values, right? So if we want to think about the general form for this one, it would be x minus okay, and that would be if the transverse axis is in the horizontal direction, or it would be if the transverse axis is in the vertical direction. So those are the two equations we need to know, along with the fact that, remember, we set b squared equals c squared minus a squared. And let's write it that way. Write it that way because here's why. Right? If we think about what we have, we see that the c is larger than the a. Remember, this is very similar to what we had in the ellipse. The ellipse was a squared minus c squared. And so if we just think of ourselves, hey, the focus is outside the vertex, that will tell us that the c is larger. So it would just help you to remember it. So right, I should add that to your formulas for yourself. Okay, so those are our formulas that we're going to use right there. Okay, there's one other important thing to note. Okay, and let's say we take this equation. Let's just solve for y squared. Right, so if I can solve that one for y squared, I'm going to just see. Let's see. I remember this is the formula. Oops, sorry. Okay. Okay. So if we're going to solve for y squared, how about I move, sorry, focus is not working. Let's see if we can get this to focus. And sometimes if I just adjust where it is, it'll focus. There we go. Okay. So I'll move this over. I'll move the 1 over. Okay. And then if I multiply everything by b squared, I get this. Okay, so this is just a constant. Okay, for self. Okay, so and if we think about what's going to happen for this, right? If we have really, really large values of x, right? If we make this super, super duper large, right? It's not going to really matter what we subtract by, right? This part over here is going to take over. So, for example, if this is 1,000 and we square it, this becomes 1,000,000 times some scalar, right? It doesn't matter if this is -2 or -4. or -3. If you have 1,000,000 times some scalar, that's going to really take over. Right? So this is going to become insignificant. And so for large values of x. Okay? So our graph approaches y squared equals b squared over a squared x squared for large values of x. And when I say large values, I'm talking about the magnitude of x. So it could be if it's like -1,000, the same thing would happen. If I take the square root of both sides, I get this. Right? This is the, remember on the video I was showing you how it looks like it approaches the line? That's the line it approaches. So this is the equation for the asymptotes. Asymptotes. Okay? And that's another thing I should add here, right? So in addition to that b squared equals c squared minus a squared, right? And we're going to have and that's going to be important, that we need to know that this is the equation of the asymptotes. Okay, for ourselves. Okay. And the last thing is that eccentricity is, again, C over A, and we'll keep that in mind when we do these things. So that's what we basically need to know for equations.